So, for question 6, it tells us to prove that radical 3 is not, messed that up, is not an element of Q, right? And you have to prove by contradiction, right? Spelled everything wrong, but it's fine. And if we remember from the last test, Q is like rational numbers, right? And then rational numbers is basically you can write something as an integer of two fractions, um like 0.5 is a rational number. You can write that as 1/2. But radical 3 is not a rational number. You cannot write this in terms of a fraction, right? But we already know that, but we have to prove that that is the case, right? So in proof by contradiction, what you do is you flip the statement and negate it. So radical 3 is not an element of Q. That's the prompt. We turn that into radical 3 is an element of Q, even though it's not, because that's proof by contradiction, right? Now, remember how we said that if it's an element of Q, it's a rational number, and rational numbers can be written as fractions, right? So now we have to verify that. So now we can write radical 3 is equal to a over b, where a and b are just integers, and then b cannot be 0, and then a and b cannot be reduced more, right? That's just what the TA told us. And then once you have that, this is just the logistics behind it, and you go from here. The pretty obvious thing to do now would just be to square both sides, right? To get rid of the radical. So it's going to be 3 over a squared over b squared. And then let's say you're solving for a, right? That's going to be 3b squared is equal to a squared. Now, if you look at this, you're going to realize a couple things, right? A squared is equal to 3b squared. If you forget about the b and focus on the 3, then anything multiplied by 3 is a multiple of 3. Like, what's 8 times 3? 24. 24 is a multiple of 3. Anything times 3 is just its multiple, right? So, a squared equals 3b squared also means that a squared is a multiple of 3, and so is a. You know? So, if it's a multiple of 3, we can bring another term in. We can just say that a is equal to 3k, where k is also any integer. Right? Cool? Now that we have that, we can plug that in here. We can be like 3b squared is equal to 3k squared, right? Now that's going to be 3b squared is equal to 9k squared. And if you solve for b squared, you're going to get 3k squared. Now, you're going to come to the same conclusion for b. So you're going to say b squared is equal to 3k squared, right? And like we said, that anything multiplied by 3 is just another multiple of 3. That means b squared is a multiple of 3. And if b squared is a multiple of 3, that basically implies that b is also a multiple of 3. You know? And now they're both multiples of 3, right? And if you go back to our original definition, we said that a and b cannot be reduced more, right? Now, if we go back here, like we're going back there and coming back down, we said the essence of a rational number is it could be written as a fraction, right? So if you write this as a fraction, I guess a would be 3b squared, and then, wait, that's a squared. Actually, it's fine. You don't need to write anything down. But if A is a multiple of 3 and then B is a multiple of 3, then you can obviously reduce it further, right? Like let's say A is 27 and then B is 9. Oh, wrote 9 wrong. You can reduce this further, right? They're both multiples of 3. 3, 3, and then 3, 9. And then you could reduce it even more further. Whatever number it is, if you multiply it by 3, you're gonna get something that's reducible. Now, since A over B is reducible, and we said rational numbers are not reducible, A nor B, oh no, we're not proving that, to be honest. And we said rational numbers are not reducible. Radical 3 is not an element of rational numbers. The leap from here to here would just be because if you, for proof by contradiction, you just follow logical steps and then you reach something that isn't true. Like we came to the conclusion that uh, A and B are both multiples of 3, and if you put A on the numerator and B on the denominator, you can cancel them out and you can reduce them more. But the essence of a rational number is that you cannot reduce it more. So if that's the case, then if we only followed logical steps, the only conclusion we come up with is that the original starting point is flawed. So the original starting point was this, right? That radical 3 is an element of rational numbers. That's wrong, because obviously it's not. So there you go. That's how we proved it by contradiction.